Seizures and Epilepsy Part 2. Video no more that South Indian accent. And what are the types of seizures? In seizure types, we have first of all tonic seizures. It presents with sudden stiffening of muscles. Okay, it presents with sudden stiffening of muscles, and the person falls backwards. Okay, as we remember from the mnemonic TB. Okay, after this tonic, we have clonic. Clonic. In clonic, there is repetitive contraction and relaxation of muscles, which is usually rhythmic, and the person is sustained in that position only. After tonic, clonic, then atonic. In atonic, sudden onset loss of muscle tone. There is sudden onset loss of muscle tone. There is sudden onset loss of muscle tone, and the person falls backwards. Okay, sorry, not backwards, and the person falls forwards. Okay, it's like this. There is going to be tonic, clonic, atonic, tonic, atonic, clonic, and in atonic the person there is a lot of muscle tone, and in myoclonic, there is repetitive contraction and relaxation of muscles, which is usually non-rhythmic in this case, and they can be jerky too. Okay, now talking about the tonic, clonic seizures. They are the most common type which is seen, and the last one, non-motor general type of seizures, they are absence seizures. In EEG, now coming to the part of EEG. Now what happens in EEG? Now we studied seizure types, and now we are going to study EEG in detail. In EEG, there is going to be in EEG, there is going to be something like this. Okay, now first of all, this is the diagram of an EEG. It records the potential difference. Okay, EEG records potential difference between two leads. EEG records potential difference between two leads. And now, since the leads which are used, they are placed on the brain, let us know about the structure of the brain first. For example, this is a normal brain, and this is something like this. I don't know, rough structure of the brain. Now, this is the frontal part of the brain. This one is the parietal. This is the temporal part of the brain, and this is the occipital part of the brain. Now, what happens when EEG leads are placed? The EEG leads are placed according to the 10-20 system. Now, what is the 10-20 system? For example, this is the normal person's head from the upper view. This is the nose. These are the ears. And what we have here is the head is divided into, this is the temporal side, this is the occipital, and this is the parietal bones. Now, what happens in by placing leads? This is the nasion, and this part is the inion. And the nasion we have FP1. Okay, frontal leads are first of all FP1, then FP2, then we have F7, 7 followed by 3, followed by 2, F7, 3, 2, F4, F8, F7, F3, F2, F4, and F8. Like this only. F7, F3, F2, F4, and F8. Okay, these are the frontal ones. 7, 3, 4, 2, 4, 8. Okay, after that, in the center of the upper side of the head, we have C2, C4, F4, C4, C2, and C3. These are the central leads, and the temporal side we have T3. Okay, just like this. We can see that pattern over here. T4, T5, T6. Okay, these are the central leads, temporal, then we have the parietal leads. P2, P3, P4. Done. The occipital ones are O1 and O2. That's it. Now connecting these all. What we are going to see pattern something like this. Okay. Oh my goodness. Okay, pattern something like this. A circular pattern with the cross in between. This is just to remember. Okay, T3, C3, F3, 4, 3, 4s, 2s, done. This is the 10-20 system of tracing the leads for EEG. This is an EEG normal, and EEG records the potential difference between two leads. Now, what should be the actually this 10-20 system? It is an international system which was adopted in India later on, and in this there is lead placement on head, and this, as you can see, the electrical activity, how it is of the paper, of the brain is digitally recorded on the paper only. Okay. After that, the gap, you can see the gap between two leads should be 10 to 20% of the surface area of the brain. Now, what are the normal EEG waves? The normal EEG waves, what are they? First of all, we have the gamma waves, beta, alpha, but beta, gamma. Just a second, we can make it simpler. Just go by chronological order only. Alpha, beta, gamma, delta, and theta. Okay. Now, what are the ranges? Alpha, they are usually seen in relaxed state. Okay, relaxed state or light meditative state. But these are the important ones: in relaxed state and the light meditated states. And it is also seen in when the person is creative. I don't know what that means. When the person is recalling something, or when the person is fantasizing something. Okay, thinking something, recalling something. Okay, usually the important one is it is seen in relaxed and light meditative state, the alpha one. Now, what is the range of frequency? 7.5 hertz to 12 hertz. It is recorded. 7.5 to 12 hertz is the recorded range. Now, beta waves. Okay, they are seen in awake state only. Beta waves, awake state is the most important one. And after that, normal waking state. Okay, normal waking state. And when the person is concentrating, not recalling. While recalling, we are using alpha wave. But like me, when when I'm making this video, I'm concentrating. My brain is in the highest active state, and the EEG waves recorded at this time will be beta waves. And since right now I'm also concentrating, focusing, and I am using my 5 physical senses. Okay, I'm in awake state, I'm concentrating right now. Okay, while making this video, I'm focusing and I'm using my 5 physical senses. Now, what is the frequency of the waves? 12 to 30 hertz is the frequency that is recorded. Frequencies must be remembered. After that, gamma, alpha, beta, gamma. Gamma waves, they seen during complex motor function state or during problem solving state. Gamma waves. And again during concentration. Right now I'm concentrating. I'm also for example, while I'm solving maths. Okay, I am doing a problem solving state, or while I'm solving any kind of puzzle. My mind is in problem solving state or in a logistics state. Then my brain is emitting gamma waves. The gamma waves, they are 30 to 100 hertz in frequency. Okay, alpha 7.5 to 12. It is a relaxed state. Beta a bit more, 12 to 30. Gamma, I think it has the maximum number of waves, 30 to 100, because my brain is performing complex motor function state. Delta. Now, the delta waves are seen in deep sleep or coma. D for delta, D for deep sleep. D for delta, D for deep sleep or during coma state. Only these two are important. And after that, it can also be seen in dreamless sleep or AKA the non-REM sleep. Or when the person is unconscious due to any reason, delta waves are seen in that case 0.1 hertz to 4 hertz. 0.1 to 4 hertz. And we can also say less than 4 hertz. Okay, the maximum frequency is in gamma state and the least is in delta state. Then we have theta waves. Theta waves, they are seen in deep meditation. In light meditation, just remember this: 80 at. When the person is in light meditation state A, when deep meditation D. Theta during deep meditation or light sleep. Because when the person is sleeping, the person will go into delta phase. It is the deep meditation. If the person sleeps after deep, then it can progress to delta state, ATD. Just remember that: deep meditation or light sleep. Or light sleep state. After that, Theta waves, they are also seen in focusing, recall, whatever. Only these two were important. I don't know what that means. Gamma waves, they have the highest frequency, so definitely in a given period of time. For example, in the interval between 0 to 1 seconds, 3.0 to 1.0 seconds, the gamma waves are going to be like this. Okay, not that symmetrical, but still just a rough idea. These are the gamma waves. And after that, the beta waves. The beta waves, they are going to be, first of all, the most highest frequency was of gamma waves, followed by beta waves. Then the next will be beta, gamma, beta. The frequency will decrease a bit, okay? 0.0 to 1 second, okay? Beta, gamma, beta. After that, gamma, beta, then alpha. Alpha, the waves will, the frequency will again decrease. Alpha, gamma, highest, beta, then alpha. Then following that order of ATD in theta, during theta waves, the frequency is 4 to 7.5 hertz. Okay, like this. And the last one, delta waves. The delta waves, they are going to be like this. When the person is in deep sleep. It's a rough idea. These were EEG brain frequencies. Okay, now seizures. Now what happens in seizures? These were the normal EEG waves. Now what happens in the state of seizures? When the person is having seizures, an abnormal activity of the brain is recorded. Okay, and the seizures are often accompanied by abnormal epileptiform discharges. Now what are in seizures, abnormal epileptiform discharges. What is the meaning of epileptiform? The waves which are seen in epilepsy. Similar kind of waves are also seen in seizures also. They can be spikes, okay, spikes. They can be sharp waves. They can be any kind of slow waves, spikes, sharp waves, slow waves, or sharp spikes. No, sorry. They can be, just remember, spikes, sharp, slow waves. Now we can combine these and get the other kind of waves. Spike, slow waves. Okay, spike, slow waves. Spike, sharp waves. They can be spike, slow waves. They can be spikes, sharp waves, and they can be poly spikes also. These kind of waves are seen. Now, how do you define a spike? What is a spike? If duration of wave is less than 70 milliseconds, then it is a spike. Okay, for example, this is a normal wave. Okay, if the duration is less, like in seizure, less than 70 milliseconds or something like that, this is, the duration is less than 70 milliseconds, then it is a spike. Okay, after that spike, after spike we have sharp wave. If duration is between 70 to 200 milliseconds. Okay, if the duration is between 70 to 200 milliseconds only. Okay, sharp wave. Just a second. Okay, now this is a normal wave. First of all, we got a spike. Okay, it was pointed again. And if similar kind of pointed wave, which is seen in 70 to 200 milliseconds only. Okay, sharp wave. This is again the normal wave. Now what happens in a sharp wave? Okay, now in this case the duration is 70 to 200 milliseconds only in case of sharp wave. Now if duration is, what is a slow wave? If the duration is less than 200 milliseconds, okay, slow waves, not more than that, but still, sorry, not less, there will be more than 200 milliseconds. If the duration is more than 200 milliseconds, then the wave is known as slow wave. This was the normal wave. If the duration is, if the duration is more than 200 milliseconds, then it is known as a slow wave. Okay, and a poly spike is somewhat like this. This is a normal wave, this is a poly spike. Okay, now what are the other epileptiform discharges? Now let us guess. Now I'll put some questions and we are going to guess which kind of spike or shape, whatever that thing is. Now these are the different forms of epileptiform discharges. What are the different forms of epileptiform discharges? First of all, there is something like, okay, something like this. This is A. This is B. Okay. Now then coming to C. C. Then D. What is D? Something like this. Okay. This is E. Then F and G. The time will be sound F. In F we have and then last okay. Now the first one is the spikes. Definitely these are spikes. Now the second one is, there is a spike and there is a slow wave. So the second one is spike, slow waves. Now these are the sharp waves. First of all, we have spikes and spike slow waves, then sharp waves, not the spikes, but some broader than the spikes. Then these are the sharp waves. Then we have sharp slow waves. Okay, these are poly spikes. After that, poly spike, slow wave. Then, as there are so many spikes in the rhythm, poly spikes rhythm. Okay. Now there is a special point we mentioned, this poly spike, slow wave, this kind of complex. Okay, poly spike and slow wave complex at 3 Hz frequency. It is seen in childhood absence seizures. Less than 4 Hz we have seen the frequency in delta waves. And if at 3 Hz only poly spike slow waves are seen, then the person is suffering from childhood absence seizures. Now what are the epilepsy syndromes? Coming to the last topic, epilepsy syndromes. Okay, now what is a syndrome? First of all, this is the syndrome. Then we have the age of onset, seizure type, and at the end, EEG pattern. Syndrome, age of onset, seizure type, and EEG pattern. In syndrome, we have, first of all, in children, starting from infants and children less than 1 year of age, 2 types of syndromes are seen. The first one is West syndrome or infantile spasm. West syndrome or infantile spasm. West syndrome or infantile spasm in less than 1 year of age of children. And the other syndrome, that is Dravet syndrome. It is pretty hard. Okay. West syndrome or infantile spasm or Dravet syndrome. The seizure type is West syndrome. The seizure type is infantile spasm is seen. In Dravet, febrile seizures are seen. Okay. Polymorphic, which are polymorphic. In Dravet, febrile seizures are seen, which are polymorphic. Now what are the West syndrome? What is the EEG pattern? Okay, first of all, these are something that need to be remembered. In West syndrome, we have hypsarrhythmia. Okay, remember that. This is again important. Hypsarrhythmia. West syndrome, infantile spasm, less than 1 year of age, and hypsarrhythmia. Okay, actually the hypsarrhythmia is way too haphazard. For example, this normal EEG is pretty good. In hypsarrhythmia, there is something like this. Pretty unreadable only. Hypsarrhythmia. So remember hypsarrhythmia. After that, Dravet syndrome. The febrile seizures are seen, and the EEG pattern is variable. Let us see the image of hypsarrhythmia. This is hypsarrhythmia. Okay, pretty haphazard only. And in Dravet syndrome, It is actually variable. See over here, it is pretty unreadable. Now in children which are in the age group of 1 to 7 years, what is seen? Lennox-Gastaut syndrome is seen. Lennox-Gastaut syndrome is seen. Lennox-Gastaut syndrome is seen. Okay. There are multiple seizure types. Multiple seizure types are seen with generalized tonic-clonic seizures as drop attacks. Multiple seizures are seen with DTCS drop attacks and spike slow wave complex is seen over here. Earlier we also studied about polyspike slow wave complex was also seen in childhood absence seizures and Lennox-Gastaut syndrome. Okay, they were absent seizures. Over here the seizure type is GTCS. Now coming to in the age of 3 to 13 years, there is excellent prognosis. In children of 3 to 13 years, the prognosis is excellent as they love Ronaldo. From Ronaldo, we can remember benign Rolandic epilepsy. And these are focal seizures, okay, in which there can be impairment of the control. Okay, focal seizures, in which they affect facial muscles and they are mostly nocturnal, as they are seen at mainly night only, and spikes are seen. So only centrotemporal leads are used. Benign Rolandic epilepsy, focal. From benign Rolandic epilepsy, let's say Ronaldo, F for football, F for Ronaldo, age group in which children usually like football, and spikes, as Ronaldo has spiky hair. Okay. Next, in the age group of 4 to 10 years, okay, up to 10 years. Sorry, not in 3 to 13, 4 to 10 years. What kind of seizures are seen? Childhood absence seizures. Okay, it is a polyspike slow wave complex only, and they were seen in less than 3 Hz. Okay, obviously the type is absence seizures only. Okay, this was pretty easy. Childhood absence seizures. The last one, 12 to 18 years of age. Okay, and if the person in the age group of 12 to 18 years is seen with any kind of seizure, then that person requires lifelong treatment of anti-epileptics, and the person is suffering from juvenile myoclonic epilepsy. Obviously juvenile myoclonic, juvenile age group, myoclonic epilepsy. From that we can see there are going to be myoclonic seizures, GTCS, and 4 to 6 Hz polyspike are seen. Juvenile myoclonic epilepsy. Done. Okay, so this is just a quick overview since what we have covered today. Seizure types, normal EEG, the leads, the potential difference between the leads, surface area, and what are the normal EEG waves, alpha, beta, gamma, delta, theta, the order gamma, beta, then ATD, alpha, theta, delta, seizures, what are the kinds of waves seen in seizures. Okay, what is seen? Spikes, spike slow waves, spikes, sharp, slows. Spike sharp slows are seen, spike slow, spike sharps can be seen like this only. Duration less than 70 milliseconds, spike sharp 70 to 200, more than 200 slow waves. Then West syndrome, Dravet syndrome, Lennox-Gastaut syndrome, benign Rolandic epilepsy, and childhood absence seizures. That's it. And juvenile myoclonic epilepsy.